Hello everyone. So today we're going to discuss about fuel cells, the clean power engine. What if you could power your car, your home, even a city with an engine that's silent? An engine that doesn't burn anything and whose only exhaust is pure clean water. Yep. It's not science fiction, it's a fuel cell. So, what is it exactly? Most people think it's a type of battery, and that's close, but with one game changing difference. A battery stores energy, it holds a limited amount, and once it's dead, you have to stop and recharge it. A fuel cell doesn't store energy, it generates it on demand. Think of it as a tiny continuous power plant. As long as you provide it with fuel, it will never stop producing electricity. So, how does it work? Let's look at the most common type, the proton exchange membrane, also known as PEM fuel cell. It's surprisingly simple. It's basically a sandwich. You have two electrodes, a negative side called as the anode and a positive side called the cathode. And in the middle, you have a special filter, the electrolyte. Now, the fuel. In most cases, the fuel is hydrogen. You feed hydrogen gas to the anode side. A special catalyst, often platinum, hits that hydrogen and splits it, breaking it into two parts, a proton and an electron. This is the magic part. The electrolyte in the middle, it's a one-way street. It only lets the protons pass through to the other side. The electrons are blocked. They are trapped. They have to find another way around. So we give them one. We build an external circuit. The electrons are forced to travel around the electrolyte, and that movement of electrons is what we call electricity. This is the power. It lights the light bulb, it turns the motor, it powers the computer. After doing their work, the electrons finally arrive on the other side, the cathode. Here they meet up with their old friends, the protons that took the shortcut, and they all combine with the other ingredient we have been pumping in, oxygen. Yes, from the air we breathe. And what do you get when hydrogen and oxygen combine? Yes, right. That's H2O, water. That's it. No carbon dioxide, no smog, no pollution, just electricity. A little bit of heat and clean water. And this isn't just one size fits all. There are solid oxide fuel cells which run at incredibly high temperatures and can power entire buildings or data centers. There are alkaline fuel cells, the exact kind that powered NASA's Apollo missions to the moon. You'll find them today in buses and trucks, quietly moving through city streets. You'll find them in forklifts, in submarines, and in cars like the Toyota Mirai and the Hyundai Nexo. So, if they are so great, why aren't they everywhere? Well, there are two big hurdles. First, cost. That platinum catalyst used to split the hydrogen, it's very expensive. Obviously, it's platinum, right? And second, the fuel. Hydrogen is the most abundant element in the universe. But here on Earth, it's almost always stuck to something else, like in water or natural gas. Getting pure hydrogen is an energy intensive process. If you use fossil fuels to create the hydrogen, you're just moving the pollution around. The real goal is green hydrogen, that is, using renewable energy like solar and wind. And of course, you need the infrastructure. You can't just pull into any station and fill up, at least not yet. But the technology is getting better and cheaper every single day. A fuel cell isn't a silver bullet for all our energy problems, but it is one of the most powerful, flexible, and promising tools we have. It's a way to create silence, reliable, clean energy not from a flame, but from a chemical reaction in an engine where the only thing left behind is the future. Thank you, everyone.